Welcome back, everybody, to Spring One. I am excited to present you this next talk, Spring Security 5.5 from Taxi to Takeoff. We have three speakers this time out. It's Josh Cumming, Stephen Riesenberg, and Marcus Di Coregio. Guys, take it away.
Welcome, everybody. Thanks for coming to our presentation. It's so exciting to be with everybody, to be with you live if you're catching it with us right now, or if you're catching the recording after the fact. We're happy to have you here, leveling yourselves up on application security, specifically with regard to Spring Security and finding out how it can assist with your authentication, authorization, and defensive security needs. My name is Josh Cummings, and I've been on the Spring Security team for 3.5 years now. This is my fourth Spring One on the team, and they haven't kicked me out yet. So it's a real delight to continue to be here and have this opportunity to be part of such a special community. I'm the father of 7. That sounds as crazy as it is. It's probably actually just a little bit crazier than you might imagine. And I also love frosted mini wheats. That's my cereal of choice, and I had it for breakfast this morning, and it was delightful. Let's go ahead and let our two newest members of the team introduce themselves. I'm so delighted that our team is now 6 strong, if you can believe it. We have Steve and Marcus, who recently joined the team, and let's take a chance for them to introduce themselves. Steve, would you go first, and then we'll let Marcus introduce himself.
Absolutely. Hi, everyone. My name's Steve Riesenberg. I'm just absolutely thrilled to be here. I joined the Spring Security team just about 4 months ago, and it's been a real pleasure and a blast. I've enjoyed working with the community for the last 4 months, and I'm really looking forward to what's next. As far as me, I just have 2 little ones, and I've joked with Josh a couple of times that sometimes it feels like 7, but I know it can't be anywhere near as much work. So hats off to Josh for that. That's just amazing. I am also a musician, and so when I'm not coding, I'm often playing my instrument, practicing my instrument, or performing. So that's just a little bit about me. And I think we got Marcus.
Marcus, are you on? Coincidentally,
yes, I am.
there you are.
Yeah,
Great.
I'm sorry.
We had a little technical difficulty right then. Marcus, go ahead.
All right, thanks, Josh. And so it's a great pleasure to be here today. And you won't believe it, but my house went out of power just now, and it's come back now. And it's always good when we talk about security, right? So my name is Marcos da Coregio. I have joined the Spring Security team 4 months ago, and it's been a great experience so far to be working with such great teammates and a passionate community. And a little bit from me, I'm a burger lover. I can eat burger in every meal. And also I'm a bonsai beginner. So I hope to get to Mr. Miyagi's level in the future. So this is just a bit from me. Let's hear from Steve now.
All right, and I actually just spoke, so I'm going to kick it over to Josh, and let's get this thing started.
Great, let's do it. What we have here is a web application that our theme today, if you can't tell from the title, is flights. And this web application allows pilots to request permission to take off and an air traffic controller to grant that permission. And we thought it would be fun to do a little bit of a role play here. So what we're going to do is Steve and Marcus are going to be pilots during this role play. I'll be an air traffic controller, and pilot Marcus will request permission to take off. And then something will happen that will disturb the standard operational procedures. See if you can spot it and what happens, and then we'll come back and talk about it. Take it away, Marcus.
So air traffic controller Josh, my flight 1 or 2 is ready for takeoff and submitting my permission request. Can you consider approving it? Thanks.
Your request has been received, Marcus, for flight 102. Thank you. Please continue taxiing along the runway. You'll be advised when you're ready to take off.
Hey, Josh, sorry to interrupt, but can you check your email real quick? I just sent you this email for this great meme. You just have to see. I know it's bad timing, but can you check that?
Yeah, sure, no problem. I love Facebook memes. Let me check that out. Oh, well, it's kind of asking me to log in. I'm kind of short on time, Steve. I'll check it out later.
You know what? I was trying to hack your Facebook, but you're not logged in, so you didn't fall for it. Good for you.
Okay.
Never mind.
Hey, Josh, thanks for your approval. I'm proceeding for takeoff now. See you.
Oh, Pilot Marcus, no, negative. You may not take off. You're not cleared for takeoff. There's apparently some kind of problem with the software. I'm not sure why it's telling you to take off, but please wait for, I suppose, my manual approval. Please wait. Please continue taxiing. All right, so we had a little bit of fun with everybody. Thanks for listening. You can submit your Oscar nominations at any time. What did you see here? Well, obviously this is an unsecured application, and there was some kind of interloper that was able to perform what's called a C-surf attack or cross-site request forgery, where a third party made a forged request that seemed real enough for the application to allow for it, and somebody else was able to approve the flight for takeoff without my intervention. And that's one of the many things that we need to be aware of as application developers. We're worried about all manner of security or security vulnerabilities, as well as doing authentication and authorization appropriately. And that's where Spring Security becomes such a critical component in your software stack, because a number of those things are taken care of for you or simplified to help you make the right security choice. What we're going to do in this presentation then is we're going to take this unsecured application, add Spring Security to it step by step. We have a backend REST API, we have a front end single page application, and what we'll do is we'll start with Marcus, who will add the beginnings of Spring Security into the REST API, talk about what we're doing and why, and slowly we'll move up to the front end, and then by the end we'll be doing some extra advanced things on the back end and show you why those are important. So Marcus, do you want to take it away?
Yeah, sure. Thank you, Josh. So as Josh mentioned, the backend application is totally insecure, and we are going to go ahead and start fixing it. So first, let's go to the CLI and let's take a look how the requests are looking like. So I can see my flights here, and I can see everybody's flights, and that's working well. So let's go now to our build.gradle file and add the Spring Security dependency. And because this is a Spring Boot application, we can make use of the starter dependencies and just add Spring Boot starter security. So I'll just refresh my Gradle project here and restart my application. So we are going to see some difference between the previous requests and the newest ones, and we are going to focus on the more important for the purpose of this demo. So let's repeat the requests, and now we can see that my requests aren't even being completed anymore. Instead, it's returning me a status code 401, which means that you have to provide some authentication. And the authentication here that it is expecting is the basic authentication. And additionally, it will happen to every endpoint. It doesn't matter if it's a user-generated endpoint or like a Spring Boot generated endpoint like /error. It will behave the same. So Spring Security says that every endpoint requires authentication. And this is the first principle called secure by default. Also, there are some other places where Spring Security implements the secure by default principle. One of them is the default username and password. As you may know, Spring Security generates a default username, which is user, and the default password is randomly generated every time you restart your application, and it's printed to the console. And why does Spring Security do that? So it comes again to the principle of secure by default. So imagine a scenario where you have deployed your application to the production environment, but you forgot to change the Spring profile, let's say from dev to production. And unfortunately, on the dev profile, you use the full Spring Security credentials. So if Spring Security had defined a single default password, any malicious user could try to guess the password and get access to our application in the production environment. So this is one of the reasons why Spring Security generates the random default password every time. So let's go ahead and take the password printed in the console here. All right, so we can come back to the terminal and repeat the request. And now I'm gonna pass the default username and default generated password. And we can see that it's working fine now. And this is really nice. So moving on, now we are going to talk about another principle, which is the principle of least privilege. And to exemplify it better, let's take place of a malicious user that's trying to find any information about our application. And imagine if I come here and I make a request to the index.jsp file and it returns me a 401. And if I try to request the index.html file, and instead of returning me a 401, it returned me a 404, I can instantly deduce the technology that's being used by the application, and it will help me to architect my attack. And this is the principle of least privilege in action. All right, so we have just seen that Spring Secured by default generates a default username and a default random password for you. But when I'm creating my own application, I want to provide my own user store. And the way to do that is to expose a user detail service to Bing. So let's go ahead and create a security configuration class here. And we are going to use the add configuration notation and declare a Bing of type user details service here. And for this application, we are going to have two users, which are Josh, who is the flight controller, me, and Steve, who are the pilots. So let's go ahead and restart my application here. And in our demo, we are storing the users in memory, but you can connect your user detail service to a Spring Data repository, a JWC template, or any kind of data access object that you want. So let's come back to the terminal, and now I'm going to use my credentials here. This password here is just a plain text password, bcrypt encoded, so I can just type password here and try to see the flights, and it's working. So let's just scramble the password just to see if I provide wrong credentials, it returns me a 401, okay. And we can come back to the log here, and we can see that the default password isn't being generated anymore because we have overwritten the default security configuration. And the way we were able to accomplish this is by using component-based configuration. And we have provided a component, more specifically a user detail service component as a bean. And Spring Secured uses that bean inside its security configuration. All right, so moving forward, I want to come here now because I have Steve credentials and I want to see his flights. But instead, the application is returning my own flights here. So I hand it over to Steve now, and he'll show us how to personalize the API to return the authenticated user's flights. Go ahead, Steve.
All right. Thank you, Marcus. So let me share my screen here. And so as Marcus just shared with us, we have not yet personalized our application because up to this point, we didn't have Spring Security. We didn't have an authenticated user. So we're just hard coding the user ID in here as the pilot ID. But what we could do is we could look to personalize the application using that currently logged in user. And one way that we could do that is through something called the security context holder. Now, the security context holder is a thread local, and it gives us access to the security context for the application. And this is available anywhere on the current thread, which is bound in a servlet application to the current request. And so if we access the security context, we get access to something called the authentication object. And so the authentication gives us some of that information about the currently logged in user. For example, we could see that is authenticated, tells us whether or not the user is authenticated. We can get things like the authorities, which we'll learn about in just a few minutes. We could get some details about the user and some other things. But in this case, we can also get the authentication name. And the authentication name is really just the username of the currently logged in user. So if we get that, we could use that as our pilot ID to personalize the application. And so that's one way that we could get access to the username. But you can imagine that there's a little bit of a difficulty in testing this code because I'm going to have to mock out that thread local pattern and the security context as well as the authentication. And so another way that we could do it is we could use something called method injection. And method injection is a feature of Spring that allows us to inject certain objects directly into our method. And so here, Spring Security collaborates with Spring to allow us to inject the authentication object itself directly into this method. And it resolves the authentication much the same way as this code that I've shown here. It uses the security context holder to get the authentication for the currently logged in user. So we could just access the authentication directly, and that would be a similar way. And of course, this might make it just a little bit easier for us to test the application in unit tests because we just have to mock out the authentication that we pass in here. And so let's go ahead and restart the application. And with that change, we should be able to see that I can access my own flights. So if I hit the flights endpoint again, and I use my own credentials here, I can get my own flight. So here's my flight, but if I change that to Marcus now, we should see that we can still get flights owned by Marcus when he logs in. Okay, so that's working. And so we've personalized the application using information about the currently logged in user. So I'm going to take a step back for just a moment, and we're going to look at this API. And I'm noticing one small problem here, and that is that the flights all endpoint is exposed for all users. So if I Marcus again, for example, I can go and access all of the flights. But in this case, as we kind of said at the beginning, Marcus and I are going to be pilots, and Josh is going to be an air traffic controller. So ideally, Josh would have access to information about all the flights in the system, and Marcus and I would just have information about our own flights. And so this is something called authorization. And so we can actually use Spring Security to build our own authorization scheme. So I'm going to hop over to the security configuration here. And just as Marcus added a user details service bean, we can add one for our security filter chain. Now, we'll learn a little bit more about the security filter chain in a few minutes, but what I want to show you is that on my screen is very close to the configuration that Spring Security ships with out of the box. The only thing that's different about this is that I'm not using form login, and that's because we're not going to be showing that in this talk. But otherwise, you can see that we have basic authentication enabled, and we've expressed in our authorized HTTP request block here our default security posture, which is that any request must be authenticated. And so that's great, but maybe we want to customize that, as I just said. So let's go over here, and I'm going to split the screen so we have the API on one side, and we can begin customizing our own requirements here. So I'm going to say for the flights all endpoint that we can add our own custom rule. And so maybe we could say has role here, and that would be a pretty typical use case. But down here, all of our users have the role of user. So we could change that, and we could give these users different roles. In this case, though, I want to show a slightly different mechanism. Let's use the has authority method. And so what we can do with has authority is we can use any kind of generic string that identifies either an authority or a permission or something that the user has been granted that tells us about what they're able to do. So I'll just say here for the flights all endpoint that we're going to require the authority has all, flights all. And similarly, just to make this consistent, let's go down to the flights endpoint, and we'll say that for flights, we're just going to require an authority of flights read, which is a typical permission identifier. And then for the other two, we have updates here. These are both put mappings. So let's just say that any other request that doesn't match the first two has authority of flights write. And that would be a pretty good start for a custom authorization scheme. But I want you to notice one thing, and that is that the taxi and the takeoff endpoints are, again, slightly different. And that's because the taxi endpoint is designed for a pilot to request permission to take off. So that would be Marcus and I. But the takeoff endpoint is designed to be used by an air traffic controller that approves those flights. So that requires elevated privileges. So what I'm going to do is I'm going to come over and add one more rule, and I'm going to use star to indicate the flight number. Then I'm going to say takeoff. And so we're going to say that this requires the authority of flights approve. And again, this is a special authority that we'll grant to that user so they can do that. But of course, our users don't have these authorities. So if we were to log in right now, no user would be able to do anything. So what I'm going to do is come down here, and we can go ahead and in our in-memory data store, we can use some authorities instead of roles. So I'm going to say that Marcus has the authorities flights read and flights write. And similarly, I'll have the same ones. But then for Josh, we're going to need all four of these authorities up here. So we can say that Josh has flights all, flights approve, flights read, and flights write. And so now we have the authorities that we need. So let's go ahead and restart the application one more time. And this time we'll see a little bit different behavior. First, I'm going to try as Marcus to use the flights all endpoint. And Marcus doesn't have the flights all authority. And so because of that, Marcus is receiving a 403. So this is a forbidden. And what this really corresponds to in Spring Security is an access denied exception. And this is telling us that you do not have the right authorities to make this request. And so that makes sense. If we go back to the flights endpoint, then Marcus should continue to see his flights because he has the flights read authority. So that's great. But what about making an update here? So let's say for Marcus that we wanted to update flight 102, and we're going to use a put request for that. Now we'd expect this to succeed because Marcus has the flight's right authority. But what happens? We're getting a 403 again, and that doesn't make sense. So something else must be going on, and we need to learn more to find that out. So what I'm going to do is turn the time over to Marcus now again, and he's going to show us how to debug a Spring security-based application. And armed with that knowledge, maybe we can figure out what's going on here. Marcus.
All right. Thank you, Steve. So before fixing Steve's horribly, we're gonna learn a little bit more about Spring Security and how and when Spring Security participates on the request that comes to our backend. So let's come to our application YAML file and add the login level place for the Spring Framework security package and restart our application. And starting from version 5.4 of Spring Security, we did some restructuring in our logs, and the goal was to make it very clear of how and when Spring Security is intercepting a request and how it's going along the way. So I'm just clearing the logs here, and just gonna do a valid request so we can see the logs, right? So let's come back to the logs here, scroll up a little bit. And we can see that one of the first places that Spring Secured intercepts our requests is in the filter chain proxy. And the filter chain proxy is the entry point for the request to come into Spring Security. And we can see here that the request being matched against the request matcher any request. That means that any request has to come to the security filter chain. And after that, we can see a list of filters, which will each be applied one by one in the order that you can see here. And scrolling down a little bit, you can see the filters being invoked one by one. And each one of those filters has a single responsibility, and they can continue processing the request by calling the next filter or terminate the request by interrupting and not calling the next filters. And if you are familiar with it, this is the pattern, the design pattern chain of responsibility in action. And also, this is what we call the security filter chain in Spring Security. Additionally, remember when Steve was talking about the security context holder that had the authentication object with the user details? So here in the logs, we can see that the basic authentication filter found my username in the header, and it populates the security context holder with my credentials. And that's amazing. So let's come back here to the terminal and let's see if we have the same error as Steve had. So he tried to update my flight here with my credentials. So, okay, we have a 403, the same error. So let's come back to the logs, scrolling to the bottom and scrolling up now a little bit. So we can see here that securing my endpoint that I requested, and like we can see now the error in the logs that when it was invoking the CSRF filter or the CSRF filter, it found an invalid token and responded as with a 403 status code. So what does that mean? The backend is asking us to provide a CSRF token in order to authorize this request. And this is a common mechanism to prevent cross-site request forgery, as we have seen in the beginning of our presentation. So let's go ahead and provide a CSRF token for our front end. So if I come back here, and I'm going to use the CSRF GSL. So I just declare the CSRF token repository, and that I am telling Spring Security to read and save the CSRF token in a cookie. So let's tie that. So I'm going to restart my application here. Instead of testing it via the CLI, let's do it via our front end, our single page application. So let's go ahead here and the request, and we can see that here that my flights aren't even being shown anymore. So I'm opening the developer tools in the browser, and we can see that there is a CARS error. And I'm pretty sure that most of our audience today have faced this error at least once. And there are many solutions out there on tutorials, on Stack Overflow, for example, but we are going to provide you one elegant solution. So let's go ahead and fix it. We already have our CARS DSL here, but we have to provide a bean of the type CARS configuration source. And I have to allow my front-end origin to access my API. And also, I'm going to allow credentials to be sent, the basic credentials. So I'm just fixing the imports here. And because CARS is a two-side agreement between the origin and Destiny, I have to change my front end, and I have to tell my front end that the request contains credentials. So I'm just gonna come here and refresh my front end and wait a little bit for that. And most of the times, adding the allow credentials to tool can be a code smell. So stay tuned in our presentation because we're gonna get rid of it in a few minutes. So our front end is restarting now. I'm gonna go ahead and refresh the backend application. So let's come back to the single page application, refresh, and now it's asking us to provide credentials. So I'm gonna provide my credentials here. My flights are here, and I can now request takeoff. And we didn't receive the 4P errors. So let's see why. So the pre-flight request contains the CARS headers here, so nice. And if we come to the PUT request, we can see here that the request contains XSRF token as a cookie, and also the CSRF token as a header. And this is a common pattern called double submitting cookie. All right, so we have just learned about the security filter chain and a way to protect our application from CSRF attacks. And I will turn it over to Josh now, and he will continue to improve your permission model. Go ahead, Josh.
You're muted, Josh.
Button ran away from me. I was hunting for it. Great, thank you very much, Marcus. It's great to see a working application that has cores and CSRF defense as well as authentication and authorization taken care of. Let's start to look at a couple more subtle things about authentication, authorization for the remainder of our presentation. The first one I want to point out is a couple of tests that we have here that demonstrate an issue that you may have run into before when thinking about authorization. You can see here that with this test, Marcus, we're testing to see whether Marcus can mark his own flight as ready or as ready for taxiing, requesting takeoff. And we'd expect that to work. We would not expect something else to work though. Excuse me, it looks like my test didn't run like I thought. There we go. The second though is whether or not Marcus can mark someone else's flight and can request takeoff for someone else's flight. We'd expect this one to fail. One pilot probably shouldn't be able to request permission to take off for another pilot. But we can see this test fails. We don't get the forbidden like we wanted to. Instead, if we take a look at the bottom here of our output, we can see that we get a 200 instead of a 403. It actually passed. It allowed Marcus to request permission to take off for Steve's flight. This is a classic web application security vulnerability called insecure direct object reference. The problem is that anybody that has flights write permission can hit this put endpoint supplying any flight number that they wish. One way to solve this would be to do some kind of a statement here. We could always ask if the pilot ID is equal to the currently logged in user. Using the authentication object that Steve talked about, we could request it as a method parameter. And then if this passes, then we can go ahead and change the status. If it fails, maybe we can throw an exception, like an access denied exception. However, we'd prefer not to weave our authentication behavior into our business logic. We'd prefer to be more declarative with our security. Steve has already shown some declarative security patterns by using the DSL. Let me show you some that are method-based now. This is a great spot for something called, for the post-authorize annotation that Spring Security supports. Post-authorize is an annotation that analyzes the return object that comes back from a method. And you can run a test that says something like what we just talked about. If the pilot ID is equal to the ID of the currently logged in user, then you can allow the method to complete. Otherwise, throw an exception. It's the same behavior that we were talking about putting inside this method directly. What's nice about doing it here is it's declarative and it relies on a framework to do the business logic for you instead of needing to embed it inside of your method. And in conjunction with Spring's transaction management, once this throws an exception, any kind of change to the database will be rolled back so that we don't have to worry about that commit occurring either. There are other annotations like post-authorize. There's one called pre-authorize for analyzing method inputs. There's also pre-filter and post-filter that allows some higher level collection management for method parameters that are collections or return objects that are collections. To get Spring Security to honor those annotations, we need to add the appropriate enable annotation. This enable annotation tells Spring Security that we're going to be using Spring Security's pre and post annotations, and that anytime it's seen on a method, Spring Security should intercept that and apply its own rules as specified by those annotations. So let's go ahead and try the test again. And while this is running, I just want to point out, so Ria, another member of the Spring team, gave a great presentation on testing security and doing test-driven security, which I strongly recommend. You can see that we're following similar patterns here to what she evangelized, specifically one thing that she pointed out in her talk is that we can include CSRF in these, which is important since that's what's required as part of the security contract for those requests. We can see that we passed now, and that's great. We've handled, in this particular request, insecure direct object reference. Another thing that we can do with authorization in Spring Security that you can do is we can externalize our authorization. Marcus showed us how to externalize our authentication by going to a database in order to query the users and passwords. Oh, excuse me. And what I'm going to do is show you how to do the same thing for your authorization model. I have a little thing that helps out with some of the boilerplate here. It just implements the interface for me. You can imagine, for example, that you might have a Spring Data repository that holds your authorization rules. And so we could go ahead and import that, but this can represent a number of other things, like if you're using Open Policy Agent, or if you're using some other entitlement server to centralize some of your authorization details, we can go ahead and call out to that. We wouldn't necessarily want to call out on each request though. Instead, we might want to be able to find out in some kind of scheduled event what the details are so we can cache that instead of taking a long time to authorize by farming that out to a remote service. So what I'm going to do here is just do something a little bit simple and representative of a more fuller solution that that would find this information out by querying the database. Simply put, we can use the same API that Spring Security uses to do filter-based security. It's the Request Manager Delegating Authorization Manager, which is an appropriately long Spring component. That's how you know it's a real Spring component, because it has a long name. We'll go ahead and build that component now with all the rules added. And then I just need to declare that delegate up here and use it. Let's see, Request Manager, Delegating Authorization Manager. call it a delegate, and then we can use it inside of our code. Once we call this delegate, then we'll go ahead and make our authorization decisions based on the thing that we generated programmatically by querying the database for the rules. At that point, it's a matter of importing that authorization manager and changing our authorization rules to, instead of being declared here in memory, they're declared in our authorization manager that queries the database. Let's go ahead and restart the application. I'll head over to the browser and we'll try it out. Let's see, now it's asking for my username and password as was done before with Marcus. And we can see that I can do all of the same things that I did before. No change in behavior, that's great. Let's check on the back end and make sure those work as well. If I go ahead and hit the endpoint using Marcus, oops, and I hit the flights all endpoint, we should see that the same rules are given as before. Let me just see if I can make that look a little prettier. We see that we get forbidden. However, if I use my own credentials, then we can see that it's allowed. Now, we do have just a little bit more time. So I want to show you I want to turn it over to Steve to show you one more thing that you can do to make your application even better using Spring Security, using a different authentication mechanism other than HTTP basic. But I want to elaborate on why this might be important to you. Consider the fact that like when I time this endpoint, it takes somewhere around 100 milliseconds. And perhaps that's surprising because we in this demo, we have an in-memory database. We're not doing any network calls or anything like that. What could possibly be taking 100 milliseconds? Now, I'm not going to give the secret away. I'm going to let Steve talk about that. But before we go there, I want to try something to see if it's going to help. This demo is equipped with Spring native support. So I can run a command like this, which will take a little bit long on the build if you've ever done this before. So I've done it before the demo, and we'll just benefit from the result of running this command. But you can run this command too when you download the demo and try it out. It will build a native image for Flights API. Spring Security integrates with Spring Native for all of its authentication mechanisms, all of its authorization models, with the exception of, I think there's still a little bit more work for us to do on the SAML side, but otherwise it works with OAuth, it works with HTTP basic form login, and everything that you might want to use. So let's go ahead and try it as a native image. I've already built it as a native image. Let's see if we get any performance benefit from doing that. Oh, excuse me, I've got to turn off my other one. And then let's try it again. We can see, great, we get a nice quicker startup time. It runs in about 1/4 of a second, which is more than a 10x improvement if you were looking at the startup time in my window earlier. However, if we do this, we'll notice that we're still, we didn't get any benefit on the request side. I wonder why. What I'd like to do is I'd like to turn this over to Steve to elaborate. We're going to actually change out the authentication mechanism. He'll show this and other reasons why it's valuable. Excuse me, why it's valuable for you to consider the recommendations that Steve is about to make. Take it away, Steve.
All right, thanks, Josh. So let me make sure I get the right things shared here. Okay. So hopefully you can see my IDE here. And so what Josh just showed is actually we're making requests to the API, and it's taking an amount of time because we're using basic authentication. And basic authentication, when we're sending the credentials every single time, that means that the password needs to be hashed every time and compared to against what's in our user store. And because we're using bcrypt as the hashing algorithm, that means it's going to take a certain amount of time no matter what. We can't really improve that beyond just throwing more processors at it. So at this point, what I'd like to do is switch over to a different authentication scheme. And so we're going to show actually using something called bearer authentication. And in fact, we're going to use Spring Security to validate bearer tokens as JOTs or JWTs. So in order to do that, I'm going to switch over to our build Gradle here. And instead of just bringing in Spring Security, what we can do is bring in the OAuth 2 resource server support. And this will bring in Spring Security as well, but in addition, it has this resource server module in OAuth 2 that's going to allow us to perform decoding these tokens and using them as our authentication mechanism. So let's see how that would work. So if we come over to our Spring Security DSL here, we can get rid of basic authentication because we won't be using it anymore. And I'm going to actually get rid of CSRF as well, because we're going to move that in just a moment to another component in our architecture. And instead, what I can do is I can use the OAuth 2 resource server DSL. And if we want to support JOTs, then we can use a little shortcut here, the OAuth 2 resource server configurer, which will configure us to use JOTs out of the box. And now that's it for DSL changes. We're ready to actually decode tokens. However, we need to do one other thing, which is we need to contact some kind of authorization server to mint those tokens for us and to give us some secure keys that we can use to verify a signature on them. So I'm going to open up our Spring Security application YAML here, and I'm just going to add a couple of properties. So we could get by with just the issuer URI here, and this is an issuer for an authorization server that I'm running already. And just a shameless plug here, Joe and I gave a talk earlier about the Spring authorization server, and that's actually what auth server I'm running here. But in addition, I'm going to provide the JWK set URI, and this is because we want that startup time that Josh just showed us in our native image to be as fast as possible. Otherwise, we could get by with just the issuer URI. So with that, we'd be ready to restart our application, except for one small problem, and that is that we have these rules, these authorities stored in rules in the database. And so we need to make sure that when a token is decoded, the authorities match. And so I'm just going to add one additional bean here, and it's this JOT authentication converter. And I'm not going to describe in detail what this is doing as we're winding down on time, but I do want to say that this is going to make sure that our authorities come back and match as they did before. And so I'm going to restart the application here. Okay. We're going to come over to our terminal, and very quickly, we have a little bit of time left. So I'm going to run a little script that's going to contact that authorization server I mentioned, and we're going to log in directly to that server as Josh. And so I'll use Josh's credentials here. And I'm going to print out the token, so you can see that this is a JOT, and it's this long, crazy thing, and we can see what's in it. Actually, there's this subclaim, and a claim is really just a field or parameter, and in this case, this actually corresponds to the username. So much like we had with authentication name, we're still logging in as Josh. And he has scopes instead of authorities. And again, those are going to get translated into authorities in our system. So with that, we should be able to make a request. And so I'm going to hit the flights endpoint, and I'm going to grab the authentication, and that is an authorization header. And so I'm just using the bare scheme, as I mentioned before, and we're passing that token value that my script retrieved. And so we should be able to see the same result as before. We get Josh's flights. And what I'm going to do is, let's actually time this now. And so I'm going to actually switch to using curl just so that we can run a little bit faster here. And so it's running pretty quick, actually. It's not going too bad. And so if I just run a bunch of these, you can kind of see that we're getting a lot better performance. And if I were to hop back to the logs, which I won't do now, we'll see that the authentication step takes much less time. In fact, just 1 to 2 milliseconds. Now, if we were to run this natively, which I'm going to do in just a moment, it should be even faster, or at least the same. But what I'd like to do for the last step, which we have just a few minutes, is kind of jump to the end, and I'm going to go ahead and stop these two services here. Because what we can do is actually switch our entire scheme over to using OAuth as the authentication mechanism. And we're not going to go into detail about all of the steps that are required to do that, because it's just a few steps and it's a little bit more advanced than we want to do for this talk. But we will have a commit in our repo that shows you exactly how to do that. One thing I'll say, though, is that we've set up a backend for front end using Spring Cloud Gateway. And so that's in here. And so that's going to be handling our OAuth handshake for us. And so instead of actually requiring our single page application on the front end to use access tokens and store them in cookies and do things like that, we can just use a traditional authentication mechanism with the session ID on the front end. And so what I'd like to do is I'm going to jump to that. And in fact, what I'm going to do is just run all of our applications natively. So I've pre-built all of them just as Josh had done. And so we can start them up here. And so I have an authorization server, a resource server, and an OAuth client, which is actually serving up a single page application. And I'm going to jump over to my browser here. And so what you can see is I've actually been redirected over to that auth server to log in. And so I'm going to go ahead and do that. And once I get past the first authentication step, I'm asked to consent. And so we see the same authorities as before, but now there's scopes that we can consent to give the client application permission to use these things. And so I'm going to give flights read and write access to the application, and I'm going to submit. And then I get redirected back to the UI, and it works as it did before. And so that's great. And so I'm just going to clear the logs here. And let's request takeoff. And again, all of these are running natively, so everything should be fast. And there are any issues that we've had, again, you can see that commit in our repo to see how we resolve those things. And here it is. We've got a request in to be on the runway. And so, Josh, can I go ahead and log in as you and approve this flight? Is that okay?
Yeah. Sorry, negative. You're not allowed to do that. I will take care of that myself.
All right. I'm going to turn it over to Josh now, and he's going to wrap us up. Josh?
Sure thing. All right. So we talked about a lot of things today to get you started with Spring Security. We started by talking about some different principles that undergird the Spring Security API, how we think about what we produce. We talked about being secure by default. We talked about the principle of least privilege. Thank you, Marcus, for both of those. And both Marcus and Steve demonstrated the power of dependency injection from the standpoint of producing beans that Spring Security can take up, and your application reading those beans or components by asking for them via constructor injection or method injection or whatever might be the case. We also talked about some of the underlying architecture in Spring Security. It relies on the servlet filter chain model. We have our own filter chain called the filter chain proxy, and inside of that, there are a number of authentication, authorization, and defensive security filters, each one of them participating to help make your request secure and authenticated. In line with that, we showed some of the improvements to trace logging that allows you to see what's going on in each filter, why you got the 401, why you got the 404, so you could react correctly inside of the way that you're configuring it, or the way that that you're using the Spring Security API. Then we proceeded to talk about cores and CSRF, where those play a role when we're deploying into a browser, when we're a browser-based application. We talked about security testing, and again, I'd advise that folks take a look at Ria Stein's presentation, Test-Driven Security, for more information about to dive in on learning how to do testing with Spring Security. Talked about declarative security. You'll notice that for the most part, we kept authorization and authentication logic out of our application. We simply declared the appropriate beans, used the DSL, used annotations in order to configure our security instead of putting it inside of our business logic. And then finally, we looked a little bit at native support. We got to see that Spring Security supports Spring Native for a number of authentication mechanisms. And then finally, Steve wrapped up showing us some of the benefits of using a short-term credential. Not only do we get security benefits because we exchange a long-term password for something short-term like a JOT or JSession ID instead in the case of forum login, but we also get performance benefits because we're not having to hash that password on every single request. The requests perform much faster. So there are a number of great reasons to consider the pattern of exchanging a long-term cred for short-term cred. There are so many great talks about security at SpringOne this year. I am so excited. Some of these have already passed. Getting started with Spring Authorization Server, Test-Driven Security, those have already been presented, but you can catch the recordings. These others, I believe, are all on day 2, so check them out. I'm super excited about each one of them, and I'm going to try to do my best to watch those. They're all from great individuals from the security community. Thank you very much. That's it for us. You can find us over at our GitHub repo, Spring Project/Spring Security. You can also find this this sample at sjohnr/spring1-2021. Find us on Stack Overflow. You can sometimes find us on Gitter as well. We're happy to answer questions, help you out, find ways that we can improve the framework. You can find us on Twitter, Joe, Marcus de Coregio, and sjohnr. And we hope to see you in the Q&A. Thank you very much, everybody, and have a great time at Spring One.
Thank you.
Thank you.
Hey, Josh, Steve, Marcus, thank you so much for that talk. It was spectacular. And I was like, I wonder if they can get all that in a single talk. Wow, y'all did it. So, folks, with that, you can join Josh, Marcus, and Steve in a Zoom breakout. And feel free to ask them questions. And for those folks, remember at 5 o'clock, we are going to head back to main stage and listen to some pretty interesting customer conversations as well as some announcements. So folks, look forward to seeing y'all tomorrow at 9 a.m. Eastern Standard.